So welcome back.
We're going to do an extended lesson on Lesson 4.
We had two lessons already, a part 1 and a part 2.
This is going to be Lesson 4, Part 3. We're just going to kind of explain a little bit more about simplifying square roots. Again, square roots are closely related to squaring a number. So when we give you like 3 squared, we know that power of 2 means to multiply 3 by itself. It means 3 times 3, which in turn would be 9. Now what we have to do is, like with every operation, we said like addition has subtraction as an opposite operation. Subtraction, the opposite operation of subtraction is addition. We also modeled, multiplication has an opposite operation that works backwards, which was division. And division is closely related to multiplication, because if you work division backwards, that would be a multiplication problem. So squaring has to have its own operation that's backwards. And we've introduced what's called the square root symbol. So what we learned is, when I take the square root of 9, that answer is going to be 3. So what we're doing is we're kind of going backwards again. We're starting with this 9, and we'll get back to that root number of 3. So it takes us back. So again, the only way you can take the square root of a number and get a whole number answer is that number has to be a perfect square. So a perfect square is something that's going to actually have a square root. If it's not a perfect square, it won't have an actual whole number answer. So for example, 36 is called a perfect square. The reason 36 is a perfect square is because the factor 6 is multiplied by itself. 6 times 6 is going to give me 36. So therefore, 36 is called a perfect square because it has that 6 twice. So when I see that 36 equals 6 squared, 6 times 6, that's the signal that 36 is a perfect square because it has those 2 6's in it. And that's really important when I do square roots. I have to have that pair. So the square root of 36 is that root number itself. It's that factor. So when I want to take the square root of 36, that answer is going to be 6. So the way that works is the square root of 36 is 6 because that 36 is made up of 2 6's. And the answer is just simply that 6 one time. It's that root number. So that 6 would give us our answer. So that's what happens with that. So some of the strategies for simplifying square roots is we may have to use what's called a prime factorization. A prime factorization may be needed. Another thing we want to do is we want to pair them up because, again, that pair is what it's all about with those perfect squares. And also we have to keep those leftovers on the inside. So I'm going to work a couple of examples here and see if we can make some sense of these again. The square root of 64. Well, actually, if you know your math facts, the square root of 64 is a perfect square because we know that 8 times 8 is 64. Therefore, the square root of 64 is 8. Now, if I'm not really good with my math facts, don't forget we can kind of do a prime factorization. So I can use that 64 there. And remember, if I'm doing a prime factorization, those important numbers are like 2, 3, 5, 7, 11. Those are the main ones, but keep in mind, those aren't the only prime numbers out there. I could be using like 12 is not prime because it breaks down, but 13 is also considered a prime number. There's only 2 factors that give me a 13. That's 1 times 13. There's no other whole numbers you can multiply together to get a 13. So if it has only 2 factors, that's called a prime number. So 13 is a prime number. Notice that 14 is not. 14 can be broken down with a 2 times a 7, which gives it more than 2 factors. 15 is not a prime number because it can be broken down with 3's and 5's. But notice that 17 is prime, and 19 would be prime. And I could go on and on and on. But for most of our work, the 2, 3, 5, 7, 11 works, but they don't always are the only results. Sometimes we have to look even further out on the road there with 13s and 17s and 19s. So when it comes to breaking down this 64, what I can do is just start with the 2 and work my way through these prime numbers. Ask yourself, does 2 go into 64 evenly? Well, since 64 is an even number, I know I can divide 64 by 2. So 2 goes to 64, that would be, 32 times. Then I'm looking at that 32 and I'm asking myself, does that 32 break down? Well, 2 does go into 32, that's going to be 16 times. And then I can break that 16 down again using the 2. 2 goes into 16 8 times. And 8 breaks down for 2. 2 goes into 8 4 times. And 2 can go into 4. 2 goes into 4 twice, and 2 can go into itself 1 time. Once I get that 1 there, that tells me I've completed my prime factorization. So a 64 is made up of a bunch of 2's. So another way to do this problem is I could write this 64 down as a bunch of 2's. 2 times 2, 2 times 2, and 2 times 2. So what we're seeing here with 64 is it's made up of a bunch of 2's. Now, to simplify a square root, what you want to do is pair up those factors. So for every pair, that makes that a perfect square. And I have 3 pairs of 2's. So what this tells me is everything comes out of the radical, everything comes out of the square root symbol. What comes out is a 2, and a 2. And there's nothing left inside the radical, so all I got to do is multiply 2 times 2 times 2, and that's going to give me my 8. So that's an alternative way to do the problem, is using prime factorization. If you know your math facts, and you know that 8 times 8 is 64, then you're right straight into getting that answer. If you're not strong with your math facts, prime factorization is a really good strategy to kind of get to that answer. So let's look at 12. 12 is not a perfect square. I can't multiply anything by itself to get a 12. So this is where the prime factorization is very, very important to working these out. So we're going to look at this 12. And my strategy is to do the prime factorization on it. And again, I'm going to start with the 2. Does 2 go into 12? Well, yeah. 2 goes into 12. That's going to be 6 times. Now we turn our attention to that 6. Does 2 go into 6? Well, 2 does go into 6 3 times. And now we know that, well, 2 doesn't go into 3, but my next prime number is 3, and we do know that 3 does go into 3 1 time. So once I get to that 1, I've completed my prime factorization, and my prime factorization is just these numbers on the left. So 2 times 2 times 3 represents 12 in a factored form. So I could go over here and change then this 12 to its prime factors, 2 times 2 times 3. So that's what I mean by the prime factorization, is make it look like this. My next step is to pair them up. And that's what's going to come out. So I do see a pair of 2's. Now remember, since that's a perfect square, the square root is just that number 1 time, just that root number. So that tells me that since there's 2 2's, I actually just bring out 1 2. So a 2 will come out. And what I see left is that 3 didn't have a pair, so that's what we call a leftover, and he stays on the inside. So 2 times the square root of 3 becomes my simplified answer to that. Okay? So I'm going to do probably 2 more examples, and we'll turn you this and see if that helps any further. Stay tuned.